Alright, in this section we're going to be going over Extrema. And in this particular Extrema here, which I'm labeling as absolute Extrema, and that is because we are on a closed interval. And I guess when you see the graph, which I'm going to illustrate that at last in this problem here, you'll better understand what we're looking at. But let's just look at the math and how to find the absolute extrema. And what we're going to be doing is, first thing, we're going to find all critical numbers. Now I'm not going to define what a critical number is in this problem. I think I do in the next problem. But I just want to follow the steps on how to find critical numbers. First thing we're going to do is take the derivative. So that should be old hat to you, and you should be able to take the derivative of this up here. Remember, you take the 2, bring it out front. I'm rewriting everything in parentheses and subtracting 1 from the exponent. Of course, derivative constant 0. Okay, there's your refresher on how to take derivatives. Anyway, so then what we want to do is take the derivative, set it equal to 0, and then solve for x. Well, we've got this equation here. We solve for x, and x happens to be 2. Well, 2 is what we call our critical number. Now, what is this? If I take the derivative and I set it equal to 0, that means, hey, look, we want to find all values of x, of which where the, for example, if we're talking about tangent lines and so forth, where the slope is 0. Okay, where the slope is 0. And that's going to give us either a maximum or a minimum right around that x value. And right around is kind of a loose term there, but it's in the neighborhood. But okay, so we found our critical number. Now the next thing we're going to do is I go ahead and take the critical number, I plug it in back into the function, not the derivative, back into the function, and we find out what the y value is. Now what you want to do is we want to look at both of our endpoints. I take 0, which was one of our left endpoint, I plug it into the function, I get 5 out, and then we do the other endpoint, I plug 3 in, and we get 2 out. And of course this 2 here was our critical number, and remember we plugged it in, we got 1 out. So now we have 3 separate points, and what we want to do now is we want to look at the largest or smallest, however order you want to do that in. But for example, this is our largest y value, so this is going to be where the maximum occurs, and this is our smallest y value, and this is going to be where the minimum occurs. But and so we can just cancel this one completely out, right? So let's take a look at the graph. Well, I guess before I look at the graph here, this is how I've got it written out. So this is our extrema here. The maximum, and I'm abbreviating this just max, is occurring, and this is the point actually on the graph here, 0, 5, and the minimum is occurring at 2, 1, right? This was the largest y value, and this was the smallest y value. Now let's look at the graph. Okay, so as you can see, by looking at these red dots here on the graph, it's easy now to see what we're talking about. This right here is 0, 5, the point 0, 5. This is right here the point 2, 1. So remember, at the bottom of the curve right here, okay, this is where the slope is 0. Okay, the slope is 0. We plug 2 into the function and we get the slope 0 out. Now back in some earlier sections we talk about tangent lines. If we were to graph the tangent line out, find the equation of the tangent line and graph it out right here when x is equal to 2, right, you would have this horizontal line, okay, which means that the slope of that horizontal line is 0. Alright, this is our other endpoint, which doesn't, this red dot needs to be moved just slightly up, but at 3, as you can see here by looking at these red dots, right, this is the smallest, or the one with the smallest y value. It's the one closest to the x-axis, I guess you can say, and then this is the furthest one away from the x-axis. So this is where your max, your absolute maximum, and your absolute minimum is occurring.